Hello and welcome back to this Revit Basics series for MEP. In the last video, we went over the Revit interface, navigation, and infrastructure. In this video, we'll look at getting your project up and running. We'll dive into topics like configuring levels and spaces in the model, how to insert elements and annotations, how to create schedules and sheets, and some basic importing and exporting of files. A few disclaimers. In the interest of only showing what we believe will be useful to the most people, there are several things we will not be talking about in these videos. We're not going into great depth about architectural stuff or creating a model from scratch. It's assumed you'll be working from an architectural model that was provided. We're also not doing any really deep dives into any of these concepts. These videos are meant to be a sort of quick start guide. So if you need to dive deep into any of these concepts, there are other resources dedicated to that. Finally, we will not be doing much actual MEP stuff in these videos. I don't know what discipline you are. I don't want to show you stuff that is not relevant to your discipline. So again, there are dedicated resources you can find for that. So let's pretend you just got your first job where the architects built everything in Revit, your client wants a Revit deliverable. What do? You could just open up the model you got from the architect and start working, but that can cause problems. If the architect comes back with changes, you'll then need to figure out how you're going to reconcile the work you've done with their updated file. Instead, we're going to create a new model and cram the architect's file into it. If you're coming from AutoCAD, it's the same idea as using XREFs. That way, if any changes come down, you just need to update their file and everything you've laid over it will remain intact. From the home screen, we'll go under Models and select New. Here, it will ask you to select a template, of which we just have the Revit defaults for Imperial and Metric. We'll go with the Imperial template. As you can see, pretty bare bones. Since this is a brand new model and we're not using a template with which we were familiar, the first step will be to check out some of our project settings, which you can find on the Manage ribbon. We won't look at all of them, but the ones you're most likely to care about are the project information, the MEP settings, the panel schedule templates if you're electrical, and the project units. Project information is pretty self-explanatory. It's where you list things like your company, your client, issue date, address, and so on. Panel schedule templates, also self-explanatory, viewing and modifying the templates for your electrical panel schedules. We will take a quick look at the MEP settings. The top three have keyboard shortcuts if you're interested. MS for mechanical, ES for electrical, and FS for fabrication. Mechanical settings is where you can set things like predefined angles for ductwork and your list of duct and pipe sizes. Electrical settings is, of course, for voltages and wire sizes and all other things electrical. Skipping over fabrication, these next two are also for electrical. This is where you configure your load types and demand factors for feeder and service load calculations. And your building and space settings are where you can define room types for your HVAC load calcs. Let's also take a quick look at the project units. If you prefer keyboard shortcuts, this one is UN. Here is where you set up how everything is measured and how those measurements are displayed. For example, length sets the units displayed for distances. It's currently set to feet and fractional inches, but you can change that. You can also change things like how these values are rounded and whether Revit displays commas or spaces to group large numbers. At the top, you have a drop-down for the different disciplines. So for electrical, you could say set whether current is measured in amps or kiloamps, whether power is measured in watts instead of VA, and so on. For mechanical, you can set your flow units from CFM to GPM or something else. All of that gets set here in this command. Next, we're going to talk a bit about levels. We'll start by double-clicking this symbol, which will take us to an elevation view. Here, you can see two levels that were present in the template, L1 and L2. Levels are essentially how Revit identifies floors, work surfaces, anything you might want to put stuff on. The views and plans you can create are based on the levels defined in the model. We'll look at two ways you can create them. The first way is to define them yourself, which you can do in elevation views like this one or in section views. From the Architecture or Structure ribbon, run the Level command, keyboard shortcut LL. One thing that's handy with this method is you can have Revit automatically generate plan views for the levels you define. The checkbox up here indicates whether it will generate any views, and the Plan View Types button lets you set which views get generated. If you're doing it this way, make sure you press the checkbox and the button before you start drawing a level. Since we're pretending this is our MEP model, we'll select the relevant plans and deselect the architect and structural plans. You can also use this offset value to trace an existing level, and Revit will draw your new level that far above what you were tracing. It looks like the template levels are 12 feet apart, so we'll set that to 12 feet. Then we can just trace over the endpoints for L2 to create L3. So remember when I said it automatically generates those plan views? The bad news is because this is an architecture command, Revit assumes we want all those views put under the architecture discipline, as you can see in the project browser. So the next thing we'll need to do is find those views. I'll select the electrical ones. Then go to their properties, find the discipline parameter, and set that to electrical. Move the cursor off the properties palette to save the change, and the views will disappear to take their place under the correct discipline. So that's how you can define the levels yourself. But what if the architect's model has levels already defined? Do you just draw levels to match those? And what if they make changes and you need to adjust those levels? Thankfully, Revit has that covered. Before we move on, let's delete the L1 level since we won't need it. The views tied to it will get erased automatically. We need to have at least one level in the model, so we can't erase them all, but we won't actually need to delete these others. You'll see what I mean. To start, we need to pull in the architectural model. From the Insert ribbon, we'll run the Manage Links command. You can also find this command on the Manage ribbon. We'll go into greater detail about this command later. For now, let's just press the Add button and find our architectural model. This model has some things attached to it that it's trying and failing to bring over. If you run into this in a project, the warning has information about how to fix this. But for now, we'll just accept the warning and keep moving. Hit OK. And there is our architectural model. Now, we can't do anything directly with the levels in the linked model, but we can make copies of them. On the Collaborate ribbon, let's open the Copy Monitor dropdown and run Select Link. Next, we'll click on the linked model, and it will bring up the Copy Monitor ribbon. From that ribbon, run the Copy command. We need to copy multiple levels, so we'll check the multiple box here. Just as a general rule, whenever you're in the middle of a command, you can check up here for additional settings to see if there's anything useful for what you're doing, or if something isn't working the way you expect it to, if there's a setting up here that's causing that. We'll drag a bounding box to the left to select all of the levels. Then hold Shift and deselect the ones that we know we don't need, like these parapet levels. Go up here and click Finish. And now we have copies of those levels in this model. Click Finish up on the ribbon to stop copying things. And we can see the new levels by selecting the linked model and hiding it. You might notice the L2 and L3 levels we had are now gone. Because the architectural model has levels with those names, rather than create duplicates, it's just moved our existing levels to match. If you don't like that, you can change that in the settings for the copy monitor command. One last thing to note, besides just saving you time, another benefit to using this method is that if any of the levels in the architectural model change later, this model will pick up on those changes and alert you to it. Something you may have noticed, those levels we had before have blue markers while these are black. That means these levels do not have any views associated with them, which is one drawback to creating levels from the linked model. The good news is making those views in a separate step doesn't take very long. On the View ribbon, we have the Plan Views dropdown. We'll start with our floor plans. From here, you can select the type and which levels you want views for. The type informs which template each view follows, which in turn informs things like the annotation scale and which devices will be visible in those views. We'll set this to Power Plan, then hold Shift and click to the bottom of the list to select everything. It auto-opens the first view that it makes, R3, but if you look at the project browser, there are new floor plans listed under Electrical for the other views. Let's run the command again to make floor plans for the other disciplines. You'll notice when we first run the command and have Power Plan selected, the list is empty. That's because of this checkbox, which ensures we only have one floor plan for each combination of level and type. Sometimes you'll want extra floor plans for enlarged plans and so on, so you can uncheck the box for those situations. We'll do mechanical next. Select all and run the command. You can press Enter to rerun the last command. Select lighting and go back one more time for plumbing. So, as I said, doesn't take very long. Something to note, you'll notice it has these numbers in parentheses for each view. Revit does require that each view has a unique name, so you will need to clean that up more than likely. If you're at a company that's already using Revit, odds are they'll have a naming convention that you can reference. Next, we'll make the reflected ceiling plans. Workflow is the same. Just select a type, select your levels, and off it goes. We'll do the same for mechanical, and that's done. That's almost enough to get us started. If you are doing electrical, you'll probably want a single line diagram, and for that, you'll need a drafting view. Just set a name and drawing scale. Press OK to create it. And you're all set. Looking at the properties, you can see it defaulted to electrical for discipline, but if you're on the M or P side and need it to draft something, that is easy to change. So we have our building, our levels, and our views set up. If we go into one of those floor plans, like the power plan for L4, you can see all of the details the architect has laid out, but none of these areas are labeled. To be able to tell these areas apart and to do any kind of building analysis or to show locations in schedules, you'll need to define these areas. Again, some good news. As long as the architect has done that legwork in their model, Revit has shortcuts we can use to pull that information in. First, we'll select the linked model, go over to the Properties palette and press Edit Type, and check the Room Bounding box. When you define areas in a Revit model, it can use walls and doors and such to intuit where the area boundaries are. Checking this box allows you to do the same thing using the geometry in the linked model. To define the areas, we'll go to the Analyze ribbon and run the space command. There are annotation tags you can insert along with these spaces. This template does not have a tag already selected for that purpose, so we'll pick one to load in. I'll just use this one that I have prepared. From where I've run this command previously, I have the tag on placement setting enabled, which allows me to see the tag as I'm looking at these spaces, makes it a little easier to understand what I'm doing here. As we move the cursor around, you can see that it is making an attempt to figure out the boundaries of the space as we go. It's doing a decent job with this area, so we'll make a space here. Once the space has been created, you can select it and use the Properties palette to give it a name and room number, as well as set things like light reflectance values, area-based loads for power and HVAC, and so on. Now, once spaces have been created, they can be difficult to get rid of, and you can't reuse space numbers, and that can cause problems if we're just making and erasing bunches of spaces. So I'm actually going to undo out of the space creation. Now, this is a decent-sized building. Making those spaces would take a while. You might have noticed when running the space command, there's this command here, place spaces automatically. As the name implies, when I press this, it will use the geometry on that floor to figure out where all the spaces are and just make them. If we go to a different floor plan for the same level, the tags aren't here, but as we hover over the spaces, you can see where they still exist. You can open up floor plans for the remaining levels and use that command to generate spaces for the rest of the model. So we have all these spaces, but as you can see, they're all named space, and the numbers for them have just been placed in order of creation. So it would be helpful to make that information more useful. We could select each space and set that information in properties individually, or we can pull the information in from the linked model. To do that, we'll use the space naming command. The settings here are pretty straightforward. At the top, you can have it populate the space names, the space numbers, or both. At the bottom, you can have it populate all of the spaces or just those on specific levels, and it will list every level that has at least one defined space in it. We will stick with the defaults, press OK, and you can see it's pulled in the names and numbers for most of these spaces. It's not perfect. Some of them don't get populated, which means you'll need to either do some manual coordination or just run cleanup on some of these spaces. A few of them seem to be voids in the architecture or chases for HVAC or wiring. But doing that cleanup will probably take less time than it would take to create and configure these spaces manually. Once you have your model set up for most of the basics, you'll then need to create schedules and sheets. Before we do that, though, let's put a few things in the model so we actually have something to display in those schedules and sheets. Since this is for MEP, let's insert some MEP stuff, which we can do from the Systems ribbon. For the most part, these commands function similarly across the disciplines. Run a command to insert something, like electrical equipment, and you can use the drop-down at the top of the Properties palette to select from different families and types currently loaded in the project. If you need to insert something not in the list, you can use the Load Family command to go find it Or you can open a folder in Windows, then drag and drop the family into Revit. I'll go with this transformer. Once you have your device selected, you can press space to rotate it and click to insert it. This transformer is pretty easy because I can just set it on the floor. For things like panels and light fixtures, you might need to mount those to a wall. So for those, you need to select what you're trying to snap to, a vertical face in this instance, before you can insert them. Now that we have a couple of devices inserted, we need to tag them. That is, put a call out or some other identifying information on the drawing. To do that, go to the Annotate ribbon. There are several different commands for creating different types of tags, but the one you're most likely to use is tag by category. And with this command, whenever you hover over something in the model, it will figure out what category that entity is and give you a preview of the tag it will insert based upon that category. You can set which categories use which tags by pressing the Tags button. For electrical equipment, it's set to a tag that will display the type mark parameter, which isn't terribly useful in this scenario, so we'll go with this tag instead, which will show the mark parameter. With that set, we just need to click each device to insert the tag. You can also modify how it's inserted, like the rotation, whether it should have a leader, and what the leader should look like. You can also tag devices as you insert them, similar to the space command. Just run the command, enable tag on placement, and when you insert the device, the tag will come in using the specified settings. A fun fact about the mark parameter in particular, as you place entities of the same category, Revit will try to increment that mark parameter based on the last value. Just something to keep in mind if you want to use that. You can make changes to inserted tags the same way as most other Revit entities. Just select it and make your changes using the Modify ribbon or the Properties palette. Something else to note, if the tag displays the value for an instance parameter, such as mark, you can double-click the tag and change the value for that parameter without having to go find it in Properties. Now that we have some devices we can schedule, let's create a schedule that displays them. From the View ribbon, open the Schedules dropdown and select Schedule/Quantities. Now, there's lots of customization available in this command, but for this video, I'll just show you how to make a basic schedule. For the category, we'll go with electrical equipment, since that's what we have in our model. Next, we can set the fields we want shown. Let's start with mark, since that's how we have our devices tagged. We can also include information like the panel name, the family and type, the level, location, and a couple of electric-specific properties. On the Filters tab, you can add filters to, for instance, only display electrical equipment of a specific type or that's on a specific level. We'll skip that. Next, sorting and grouping. We'll set the schedule to sort by mark in ascending order from smallest to largest. The Formatting tab is handy if you want to change the orientation or alignment for specific columns, or if you want to hide a field so that it's available as a filtering or sorting property, but is not actually visible in the schedule. Again, lots of customization you can do here. And finally, the Appearance tab. Once again, lots you can do, but for this, we'll stick to the defaults. Press OK, and it generates and opens the schedule. Once you're in here, there are several controls for making changes to the schedule, whether it's going back to that creation dialog or modifying existing fields. One handy feature is you can actually make changes to the model from the schedule. For instance, none of these devices have names, but I can set them here. And as I'll show you in a minute, those changes will translate to the model. If you have the family and or type in a column, you can also change that. Obviously, things like the level and location can't be modified from here, since that would require actually moving the device in the model. The other feature I want to mention is the Highlight in Model command. Obviously, if you have a large building, it can be hard to track down a specific device to make changes to it. But if you can find it on a schedule, you can select it, run the command, and Revit will go find that device for you. And as long as we're here, you can see those changes we made in the schedule a moment ago. So we've got our floor plan set up and we have a basic schedule. Eventually, you'll need to print those to sheets. So that's what we'll look at next. To create a sheet, go back to the View ribbon and run the Sheet command. First, you'll get a list of the title blocks loaded into your project so you can decide which one to use. We'll stick with the default. Over in Properties, you see we have places to put names to the designer and reviewer, give the sheet a name, that sort of thing. Similar to the mark parameter on devices, the sheet number parameter will try to increment based on the last value that was set for that parameter. So this one is C102, the next one would be C103. If I rename this to E105, the next one will be E106, and so on. So we have our sheet, but it's empty. To put something on it, on the View ribbon, we can use the View command. Here it will ask what you want to insert. The list includes plan views, drafting views, schedules, just about anything you might want to print out. We'll go with that L4 power plan since that's where we've been working. Something to note, Revit only allows each plan to be used in exactly one viewport. So if you wanted multiple sheets to have the same plan, you would need to create duplicate plans. As you can see, after we make our selection, it gives us a bounding box for the floor plan. We'll position that, then click to insert it. Now that we have a viewport, there are a few things we can do with it. We won't look at everything, but I will show you the things you're most likely to use. Something important to bear in mind, the things you do to this viewport will impact the view that it's displaying. So if, for instance, you want the sheet to not show something, but you do want to be able to see it when you're working in the floor plan, or if you want different scales, you will need separate floor plans. Speaking of scale, you can modify the scale at the top of the Properties palette when you have the viewport selected. You could also change it from the plan view itself, as I showed in the previous video, but I wanted to show it off here because it's a better indicator of what is actually happening. Changing the scale is simple enough. Just open the dropdown and select a scale. We'll go with something smaller than what we currently have. You'll notice, of course, the view got smaller, but the text is still the same size. That's important to note because if we open up the plan view and change the scale there, it looks like the opposite is happening, that the model stayed the same, but the text got bigger. So just bear in mind, if you change the scale of a drawing mid-project, that is how the view is going to behave. Back on our sheet, if you select the viewport and run Activate View, or if you double click on the viewport, it will let you make changes on the floor plan the same way it would if you had the floor plan itself pulled up. You can double click outside the view to deactivate it. Also, on the ribbon, there's a drop-down you can use to change the plan shown in the viewport. As I mentioned before, each plan can only be used once on sheets. So if you select a plan in this drop-down that is already on a sheet, Revit will ask you to either pick a different plan or to remove the viewport from that other sheet. If you have a large building that's going to have lots of sheets, this process can take a while. One thing you can do to speed that up once you've created one sheet and gotten everything configured is duplicate it with the same properties. To do that, find the sheet in your project browser, right-click, and go to Duplicate Sheet. You have a few options here. You can duplicate just the sheet and its settings, its parameters. You can duplicate it with details, meaning any lines or symbols inserted on the sheet using annotate commands will carry over. And you can duplicate it along with any inserted views. As I said before, each plan can only be used in one view. So if you want to go this route, it will also duplicate the plan and ask how you want that duplication to work. The first two options are pretty straightforward and similar to the options for duplicating the sheet itself. Make a copy of the plan, or make a copy that also includes detail lines or symbols. The last option creates a dependent plan, which means the plan it creates will automatically inherit any changes you make to, say, the scale or discipline or visibility settings of the original plan. Similar to when you're creating sheets, it will try to increment your numbering scheme when you duplicate them. So, we've briefly covered how to do the initial setup for your model, how to put elements and annotations in the model, and how to create sheets and schedules to display information. Next up, how to import files and export your model. We dipped into the import process when we linked the model earlier in the video using the manage links command. We'll go back to that command momentarily. First, let's go to the insert ribbon where all of the import commands live. They're broken up into three panels here: link, import, and load from library. For the first two, the big difference between them is that link is similar to the xref command in AutoCAD. When you import something, it will keep track of the imported file and stay up to date if things change. Import will bring in a snapshot of that thing, but does not create a link to the original file. So, let's go back into the Manage Links command. In here, you can see tabs for each of the link commands on the ribbon. When you need to link something, you can either run the specific command, or, as we did earlier, come here to Manage Links, go to that tab, and press the Add button. For items you already have loaded, you can use these buttons to unload it from the model, load an unloaded file back into the model, or remove it from the project entirely. I won't go into exhaustive detail about everything you can do with imports, but I do want to point out the reference type. Remember when we imported the architectural model and got that error message? It was telling us the architectural model had other models nested into it, like the site model, but couldn't bring them in because they were not configured for it in the architectural model. That's what this setting does. If it's set to overlay, the link only persists in this model. If you set it to attachment and then you or someone else tries to link to this model in their project, the linked model comes along for the ride. There are appropriate scenarios for each. For overlay specifically, the big example would be if you are working in the MEP model here. You have the architect's linked model, And the architect also wants to link your model back into theirs. If we had our linked model set to attachment, it could cause some weird recursion issues where the architectural model is trying to pull in links to itself. So again, setting this linked model that we have to overlay would prevent that issue. So that's import and link. What about this other stuff? Load family, which I mentioned when we were inserting equipment before, is for inserting families into your project from your local machine or from a company network. Similarly, Load Autodesk Family opens up Revit's library of families on the cloud. Load as Group essentially allows you to define several elements in a project or family file, then bring that entire set into other projects as a single element. An example might be a bank of sinks or toilets in a commercial bathroom, where you already have a few fixtures and partitions built out, so you don't need to model them individually every time. Finally, Insert from File lets you reach into another Revit project and pull out specific elements. Say you have a view or schedule in this project that took a while to set up and you want to reuse it in a future project. This is the command you would use in that future project to pull that formatting in. So that's importing. What about exporting? For that, go to the File dropdown, and there are commands for export and print. Again, not going into great detail about these, just showing you where they live and taking a quick look at the ones you're most likely to use. For the export options, the first allows you to export to CAD files, such as DWG for AutoCAD drawings. You can export to PDF. We'll take a quick look at that. This option is also available under print, and it's the exact same command in both, so bear that in mind. You can select which views and sheets get exported. If you split them into separate files, you can designate a naming scheme, set various options for print quality, and so on. Additional file formats you can export to. For the most part, if you recognize the format, you will probably know when you would want to use it. Further down, there are options for things like video walkthroughs, screenshots, and HTML tables, as well as settings for some of these export formats. For instance, if you were exporting to DWG, you can use this to set up your layers and drawing units and such before running the export. The commands for print are pretty basic and about what you would expect for a word processor or other program used for standard printing. Print preview and print setup, pretty self-explanatory. And again, we have that print to PDF command that is the exact same as the one under export. If we go into the print command, it has your typical options to set number of copies, the range and ordering, that sort of thing. For batch print, it largely works the same way, just stripping out some of the formatting options and leaving you with a cleaner UI for just selecting and rearranging views and sheets to print. That does it for the second part of this Revit Basics for MEP series. In the next video, we'll go over work sharing, phasing, design options, and where to go for additional resources. See you there.